right? So I'm going to ask you, um, what does it mean to have the same base in math?
Well, I think it means the number at the bottom of the equation has to be the same.
Yeah, so for example, here our x's
Mm-hmm.
are the same,
Mm-hmm.
right? So that means
Right.
we have the same
Base.
base.
Okay.
Um, Based off these power rules, when I add these two that have the same base and they're to
Mm-hmm.
the power of
A
a,
number. Okay.
right? We'll call the number a.
Uh-huh.
What can we do based off what this is equal to?
Well, if they're the same base, you can add them together, right?
You can add what together?
The two x's.
Yes.
So you get 2x.
But the power, do you add those together or does it just stay the same?
I don't know.
Well, I'm at right here. If I have x to the a plus x to the a.
Oh, it's 2x to the a because it's all the same base.
Mm-hmm.
Okay.
Okay, and so now when we multiply bases with the same base, right?
Mm-hmm.
What can we do with the exponents? So x to the a times x to the a equals to
X times x, which is x, and then you add the two powers together.
exactly. So on adding, right? You can't actually change the power at all.
Okay.
But when you multiply things with the same base together,
You can add them together. You add the powers together.
yes, okay. And so the last power rule that
Is
we
the
need.
division.
And so do we have the same base?
We do.
Okay.
So x divided by x is x, but the powers are subtracted from each other.
Exactly. Okay.
Right?
So let's try some examples, right?
Okay.
And so each one of these numbers is attributable to the same. It's in chronological order of the rule that
okay.
you're going to be using. Okay.
Alright.
So here's an example right here of 2x squared plus x squared.
So that would be um,
Do we have the same base?
well,
Keep in mind, when I talk about the base, it's only the variable that needs to be
okay.
the
So
same.
yes, we do have the same base.
Okay.
So it's really 2x to the power 2 plus 1x.
Good job.
So you add the two, the x the two bases, and that's 3x.
We can call the number that's right in front of the variable, we're going to call that a coefficient. That's the actual
Oh, okay.
term for it. So you could say we're going to add the coefficients together, right?
And
And
then,
so
and then take the same the same base, and bring it down. And the powers are, you can't do anything with them. So it's just 2.
good job.
Okay.
Okay, so
And the second one is a multiplication. So the bases are the same.
now you just
Do you multiply the coefficients?
yes.
So it's 2 times 1, which
Yep.
is 2.
Yep.
And then the powers you have to add.
Yep.
So it's 4.
Good job. Good job. Okay.
And then the last one, division. So the coefficient, the bases are the same. So you take the coefficient on the top divided by the coefficient on the bottom,
Yep.
which is
So how many times does 1 go into 2?
2.
Yep.
So it's
your first
2.
is 2. Yep.
And then the bases are the same. And then the powers, you subtract the top one. You subtract the bottom one from the top one.
No.
You subtract the bottom one from the top one? No?
So this we should rewrite this power rule as let's say this is to the power of b, right? Just to help you see it better.
Okay.
You actually do xa minus b. So
you take a minus b.
yes.
So 3 minus 2
Yep.
equals 1.
There you go.
Okay.
So those are your 3 answers. Okay, so these are really nice because they all have the same base,
Right.
right? So let me give you an example where maybe things don't have the same base. Let's say I gave you 3x squared, right? Plus 4xy plus x squared.
Okay.
What could you do with that? What's a good first step?
First of all, it's a plus, so the powers don't change.
Yep.
So on the x's, it's 2. But so I would add the same bases, the coefficients of the same bases. So that's 3 plus 1 equals 4x.
Yep.
And then you take the powers, which can't change, so that's a 2.
Yep.
And then you add 4xy, right?
Good job. And that's your final answer. That's the most you
Oh,
can
that's
do.
the most you can do.
Seems weird to just, have
Right.
more than one term in your answer,
Right.
but this is
But so you're saying if there was another 4xy over here, then I could have added those together.
absolutely, and you would get
8xy.
Yep, good job. Okay, so let's try one using each one of the power rules, but with terms that are not the same. Bases that are not the same. Just
okay.
the same way we did here. So we just did an adding one, right? An addition subtraction one. Let's try this.
Okay, so we have 2 bases that are the same, the x's. And this is all multiplication?
Yeah, these are all being multiplied together, right?
So I can multiply the 2 x bases together, which would be 3 times 12, right?
Yep.
Which is
So
36.
Yep, good job.
36.
So what's the rule for multiplying things with the same base?
You add the powers together.
Yep, good job.
So that's 36x, and the 3x had a power of 2, the 12x had a power of 1, so it's 2. 2 times 1, which is 2.
What do you do with the so what does this tell you right here on the power rules? What do you do with things that have the same base, the exponents?
Oh, you add. Sorry. That's right. You're right. So that's 2 plus 1 is 3.
Good job.
Okay. And then there's a 4y times 1y. So multiplication, I multiply the 4 and the 1 to the 1, and that's 4. And then you add the exponents, so that's 1 plus 3, which is 4y to the 4th.
Good job.
And then you multiply them
And that's
together.
it. That's all you can do.
Okay, that's all I can do.
Now, this brings up an interesting point, actually. So, this rule, it's a little unclear because it tells you that x to the power of a plus x to the power of a, right? You can just add them together. But what if I gave you something like this? If I gave you 4x squared plus x to the 3rd, can you do anything with that?
Oh, because the powers are different.
Yeah, so in the past, right, in this problem right here, and in this problem right here, they had the same powers, and so you knew you could just add the coefficients together.
In this case, I can't do anything, right?
No, you can't.
It's
So
that's the farthest it can be reduced.
absolutely, because a stipulation on this rule is the powers need to be the same as well, right? Do they need to be the same on multiplication power?
Yes.
Do the powers need to be the same?
I would
The bases need to be the same, right?
But I would expect so.
Well, right here, you had 3x squared, and you multiplied it by 12.
Oh, that's right. So multiplication, they don't have to be.
They don't have to be. And then right here, on the division rule,
They don't have to be
they don't
either.
have to be either. The only time that rule applies is on adding or subtracting
I see.
for power rules, right?
Right. Okay.
Think about it this way. This always confused me until my pre-calc professor told me this once. So if you have an x squared, right? let's put it in quotation marks, right? Like I have 1x squared, and you, like, I'm just rewriting this problem, and you add 2x squareds. Let's even put an apostrophe s, right? How many x squareds do you have now?
2.
So you have 1x squared here, right? So you have an x squared. And now
Right.
I'm giving you 2
Oh, I
x
see. 2.
squareds.
So 3x squared.
Yeah. So that's why you got 3x
3x.
squared.
Oh, yeah. I get it.
You can go by that whole thing of like, oh, I add the coefficients, you know what I mean? If you want to be super technical. But if you want to think about it actually more
logically and practically,
what you're doing is like, I have an x squared.
1.
You know?
And then over here I have 2 x squares. Okay.
And there's a little, I think multiple approaches helps, but another thing that always throws people off is square roots, right? And so a lot of people would get thrown off by something like this, maybe like square root of 3 plus square root of 3. And be like, oh, forgot square root rules. I'm sure there's some rule, right?
Right.
It is actually just this simple. The answer is, well, actually, do you think you could tell me the answer? I have a root 3, and I'm giving you another root 3.
So I have 2 root 3s.
Exactly. Your answer is 2 root 3. It's just that simple.
Oh, I see. Yeah.
People get caught up in the rules and all that.
Yeah, that's a lot simpler.
You just think about it like that. It works out. Anyway, okay. So now let's do our last example of power rules, but with dissimilar basis, right?
Okay.
Let's try this one. 2x to the third times y to the third over x. Now,
okay. So, first of all, these two are the same. The
yes.
2x cubed over the x. So you can apply that formula.
Yep.
Right away.
Yep.
So that one is 2 divided by 1 is 2.
Yep.
And
Just
x, the 3 minus 1
Good job.
is 2.
Yep.
So it's 2x over 2, or
power
of 2.
Yep, good job. And
times y3.
And that's all you can do.
And that's all I can do.
That's it. Good job.